Hey everybody, it's Dennis from Elgin Network LLC, or as everybody calls me, the Mad Scientist, considering I'm the boss and I do all kinds of fun things. But this video here is I'm just going to go over to some of all the new products and new stuff I just got in. So they're going to become some of our building kits when we get going. So a whole bunch of stuff got in, so I can show you what we got, and then later on we'll start doing projects with all this stuff. So to start with, here we got the TC4 400. It's similar to the it's similar to the other little boards that are done. And I'm sorry, I'm having a long day. These are like the Androids, or not Arduinos. I'm sorry, Arduinos. But it's got actually a instead of a processing unit, this has an ARM in it. So we're going to be using one of these to help run something. So we'll have that. And this here is the audio shield for it. And if I can get the focus and get it so you can read it. There we go. This is the audio shield for the TC. What this does is the board goes onto here and it allows me to inject and get back audio sounds. And again, it's going to be critical to a project that we're going to be doing, because the TC needs to hear sounds, because what we're going to do is we're going to be making in the lines of ham radio, a radio unit that actually does what we call digital signaling, and so you can send and receive. And also we'll be converting the CW type boards into what we call single sideband boards. And that's why I got this to go with the TC. Next thing we got, just picked it up. This is the Adafruit. This is the Feather. This has both the Arduino and also has CircuitPython on it. And the reason why I like that, and I'm trying to get most of the stuff to the CircuitPython, is because the regular Arduino software is basically C programmed, and I like Python. I'm a Python programmer. So it's easier to make stuff with this. But these are great little boards. Again, this has a ARM chip on it, and so that's what makes it so good. And then we got here, this is a Leonardo design board with Wi-Fi, and also it has a ARM chip on it. And we're going to be doing some different projects with this where it can communicate with the network. It's a pretty good, nice board. You can see here this silver spot here, right there. That's all the Wi-Fi and Wi-Fi and Bluetooth. And then the rest of it's an Arduino, basically kind of like an Arduino. And then it has the chat. So it works kind of the same. All the pinouts are the same. You got your reset button over here. You got your power over here. So we'll be working with that too. That's another project we'll be going to. Just so you guys know, this is how busy we're going to get with projects, so everybody gets to know them and see them. I don't know if I showed this or not, but again, this is a special type of mini Arduino. And it's on a board, an expansion board, so you can do a lot of things with it and make it easier. Instead of having just these pins right here doing stuff, all these pins expand out to what's in here, so you have more to use and more to program with. So that's what that is. and it's a pretty neat toy. I've used them before. They work great. And if you want, you can actually put the other pins in here so it can plug into something like the other ones. So I haven't decided what I'm going to do with that yet. Or you can put the high end pins up here, the females up here, so that you can put mounting something on this. But for now, we're going to leave it that way, and we'll figure out what changes we're going to make to it when the time comes. And sorry for my camera, somehow it likes to autofocus a lot. And then we have the ST board. This is actually, again, a very nice developer board. Has a LED screen. It's got a lot of different things built into it, and there's a lot of neat projects we can do with this. It's very inexpensive. It has already places on here to add stuff to it if you want to make changes. You can put a crystal on it. You can put headers on it to use for different things. So we're going to be doing a little bit of programming and working with this, and let's see what it can do and see how fun it's going to be to make projects. And next up, we got a lot of times we do programming stuff and we get cables. Well, most of the cables are 10 pin, which is that, and then we want to go into the header of one of the boards. Let me see if I can use this. What this does is you have a 6-pin header here, and what this does is it'll plug right into the 6-pin and go to the 10-pin, so you can do programming. So that's what those are good for, and they're very good to have. And one of the things we're going to show you how to do if you don't want to spend a lot of money but you still want to make projects. These are the Amtel chips that I got, and basically you can get them either pre-programmed with the bootloader, or you can put the bootloader on them. And so these are actually what the Arduinos use, is these chips here. And so I've got a bunch of those because I want to make some custom boards, and I don't need to have what they've got, so I can limit stuff and still have the chip that I need. And the other thing we got here, which is kind of crucial, this is usually one of the ways we can program just about anything we want. What this is, and I'd highly suggest when you get time, it's the Picket 3. It's a programmer, and this you would absolutely have to have if you're going to be making your own boards or making changes to stuff. You want to have these. They're not very expensive, they work great, and then they also come with this board here that you can connect to, and this is where you have the ZIF socket. So you put your set up in different points of where to put the different size chips. So you put them in there, lock them in, and then you can program on this board. And it also comes with the cable that go from the programmer to the board, and it also gives you the USB for your computer, because the programming that you do is you put it in there and it goes through the Picket and then into the board. So again, this is stuff you'll probably want to look at in the future, especially if you want to make your own projects. You know, instead of buying pre-made Arduinos or anything that has a microprocessor in it that you have to program, just the way to go. You can get your own chips, you can design your own thing, and you're good to go. Okay, and again, this is a different type. This actually, what you do is you take the main Arduino chip off of your Uno, and you place this shield pins on it. So you place this onto your Arduino, and then what you do is you open this up again and you put your chip in here, lock it, and you go through here again with the programming. So it feeds into here, goes through the other one, and comes into here to make your new chip that you want. We'll program with what you want on it. For instance, like I'll take them and put them in here and add CircuitPython to them. So that's what I use that for. So again, not very expensive, but it gives you more room to do things that you want. You don't have to always be buying certain stuff all the time. You can buy a lot of cheaper products for what you want to do. And I got here, it's all sealed, but in this little kit here, I'm going to try getting it so that you can sort of see everything. As you can see, there's a lot of different parts in it. You can see there's the socket, and right next to the socket is the arm tail, and these are the headers and the different electrolytics. This side we've got some LEDs. So basically what this kit has the crystal and everything, the transistors to bring the voltage down from to 5 volt and 3.5 volt. And what this is called is make it your own Arduino. So basically everything here you can put on a board and you have your own Arduino. It's $9. So that's how cheap you can make one. $9. And you have a full-blown Arduino. So if that's something you want to do and something you want to learn and something to have fun with, I would suggest doing this, because you get to learn more on how they work. You know how easy it is to program and to make them. Next, I've got going a little bit on the other side of things. Besides my company doing computers and stuff, we do a lot of different things. But computers is our main stuff, and selling, fixing. But the other thing too, a couple of us do, and I guess they go kind of hand in hand on things. I'm a ham radio operator, so what I like to do too, and get people interested in these, and they're very easy. They're the children, well, not children, but younger children, teenagers can build these, and they're far cheaper than buying the equipment at a store if you're just starting out. This right here would be a 45 watt single sideband amplifier. So that's basically all you need right there to put it together. So basically what I'm doing is I'm going to be putting this kit together, and it comes with a board, and I'm going to be putting this kit together, and then what I'm going to do is I can make some changes to it which are fairly simple once you understand, so that it is going to allow, besides CW or single sideband, it will allow digital, so we can run digital. And the reason why we do digital, a lot of things that affect ham radio the most is sun. And right now we're at the low end of the cycle, because there's cycles every so many years, where we have a lot of sunspots and we have little sunspots. Well, when there's a lot of sunspots, the radio's open. You can get everything everywhere. All the different frequencies are good. When you have less sunspots, it's very hard to get out, because there's less room for stuff, and the sunspots is what helps us to communicate. So right now we're in a low sunspot, but with building this and using the digital modes, what that does is it allows you to bring a signal through the noise and can be picked up and picked out of the noise and still be able to talk to somebody back and forth, even though it's not clear. The digital stuff is designed to be pretty much hidden in all the noise, but it still can see and understand. So that's why we do that when it's bad. This is another way for us to communicate. That's kind of why military and everybody else went to that. There are digital systems now besides voice systems, but the old days they used to use CW, Morse code, but they gave that away because they're doing all digital communications, because digital communications will work no matter what the condition is. So, and make one of those and have some fun with that. And this is a 3-watt. But this is a 3-watt CW transceiver. So it's for doing CW on it. But what we do with these is they're designed in a way that we can, I'm trying to get it so you guys can see more of it. What we can do is we leave certain parts off of this, and I'll show you in a second what we're going to do is we don't put the crystal in, we add something to it that is what we call a crystal oscillator that is variable. So instead of being stuck with just one frequency, we can adjust to many different frequencies. So instead of this being just 40 megahertz, this one I can set to go from 40, 30, 20, 17, 15, and so forth. But I'll show you how we're going to do that. But this, again, they're very inexpensive kits. There's another one similar to this. If you want to wait for it, I'd say to order a bunch of them. It takes a while to get them. They're like about $3. So $3 for this. Another, I think it was like maybe $9 for the amplifier, and you got yourself a nice high frequency rig. Okay, so what I got here is 2 different types of what we call these are 88, and they are the SI 5351 clock chip. What these do is these are clocks for clocking circuits, and the ends of it you can either put connectors on, or you can just solder directly to them. There is 3 clock circuits in this, and that's 0, 1, and 2. What these are used for is, again, when we make what we call a VFO DDS, we need to have this because this helps with the timing of the different frequencies that we adjust to as what a crystal does. So this is from Adafruit. This is from another company, so I decided to try 2 different ones. They're pretty much similar, but sometimes some seem to be nicer and cleaner than others. So basically that's what I'm trying to do. And again, sorry guys about all this. I just don't want to having issues with the computers, so I'm using this one, and it doesn't like my autofocus sometimes. But you'll see more later. All I'm doing here is showing you. This here is another, this is an LC technology board. Again, this is a little board that we use for doing certain things. I know a lot of them probably people haven't heard of, but if you look them up, There's a lot of different projects you can do with these type of boards, and so that's why I order them, because the things that I make, being the weird scientist that I am, that's why they call me that. I kind of make some fun and strange things, and I get sometimes the guys going, "Oh no, that won't work." And I'm like, "Yep, watch this work," and then I get it to work, and they're surprised. So, anyways, so we got that. Another thing I suggest getting, this is one type. These are called rotary switches. What they do is they allow you to adjust frequencies when you're using the VFO. So when you turn a knob, it keeps changing the frequency, and it has a little press button to switch to the higher numbers. So you can press and move the bigger numbers, and then press it again and then move the smaller numbers to fine tune it. And it does come with a cap with it. This one is the type that goes on a printed circuit board or whatever you have, because it has pins. I have others that don't. I ordered these, they're cheap. I order them, have them on hand, because again, I use them for different projects, and that's why I have them. And then this, I'll actually open this up so you can see it. This is, again, another sound and timing and pretty much a crystal board, which is what we use in the digital readouts for the ham radio. So when we dial up the band, this goes through it. This does a lot of the conversion information, and it also helps to, again, sync to the exact oscillation that's needed for that frequency and sound and injection and everything, so that it will work on whatever frequency you want. So again, these are great. You can either use these, or you can use the other little ones, the SI 595s, or you can use both, depending on what you're doing. I'm actually making a special circuit where it's actually going to be using both of these, but that will be a down the road, but it will be a fun project. It's something you'll learn, you'll think it's cool, but it takes a single channel transceiver, and we can turn it into a multiple channel transceiver. Let me put this guy back in here. See, some of the stuff I don't like to take out of these bags because, again, static electricity bothers them. And those bags, they're fine. And then what I have here, again, this helps with a lot of different projects. When you do programming, or you do certain stuff, or when you're done, you want to make something that's going to give you information. This here, I can open this one up again. It's not going to hurt it. These are just liquid crystal. What this is this is a small liquid crystal display. And what we do with these is it has a little plug on here on the back. And it plugs right into your Arduino, or you can use them with the Pi boards. And what this does is it plugs in, and you set it up so the information reads across there. So it's a nice little toy. Gives you something to show what you're doing, what's going on, what's been inputted, what's been outputted. So it helps you to know what's going on. So these are great for doing that. They're not, again, I bought this $2, I think it was. I mean, they're very inexpensive. So use those. Let's see here. This is, let's see what this one is. Yeah. These are the two similar to that. And sometimes you get to buy them in 2s, 4s, and again, they're extremely cheap to get them. They're small, but they do what you want because you just want enough information that it's going to show. So there it is. You can see how big it is. My fingers are bigger than it, but this will display enough information on it that you want. And it also got where here the holes that you put the connectors in here, so you can plug it in and it'll read everything. And in this packet you get 2 of them. So that's why sometimes I order stuff in 2s. It's cheaper and I can always use them for something. Just remember, any type of parts or anything you buy, think of it as an investment. You're not going to waste any money on it. You're not going to waste time on it. It's going to be something that you're going to want and need some point down the line. Okay, so I got another one here, which is a little different. This is what we're going to use in some of the readouts for the ham radio. And again, I haven't opened this yet, so I will, so you can see it. There we go. This is a, why is it I have a crack? This is a square design, and it's actually designed for blue and yellow color on it, and it'll give you a lot of readout information. It can do certain graphic stuff on it. It has the pins on the back right there, so you can pin it into the board, and there's drivers for all this stuff, and it explains how to use it. But again, these are great little LEDs or LEDs, LCDs for what you want to use them for. They give a lot of information. You can program them so that certain switches, every time you push a switch, it gives you different information, and so they're very helpful and they're very inexpensive. Okay, so we're getting down to some things here. Oh yeah, this again is another ham radio project, which I will be making and showing everybody, which is some of the fun stuff. This is actually a digital mode transceiver, and what it does is it's got a little screen on it. We set it up, the antenna goes to this, and basically it goes, you can run either directly to this, and it goes into the internet. And what this is used for is if you have a Yaesu radio, Yaesu has their own digital product. If you have a D-Star, it does D-Star. It also does DMS, a lot of other stuff. So it's a great handy thing to do. We call them hotspots. The reason why is because we can set it up around our house. We can still use our handheld to talk to this, and goes out to the rest of the world. So it comes with that, comes with screws, comes with that, and then they also give a nice metal case with it. So that's what I'm going to do with that. But it doesn't work very well by itself, so it needs something to go with it to work. So what I have done here, is I bought a complete, this is a Pi Zero kit. So it's a Raspberry Pi Zero, and it's got a whole bunch of stuff with it. And basically what I'm going to do is I am going to take this Pi Zero and have that other card mounted on this and programmed so that it will all work together. This has got a lot of other stuff in it, so I'm okay with that, because all I need to do now is I can use one Pi on here, whatever I don't have and use in here. Alright, I can spend another $19 and get another Pi 0 and still have stuff to do with it. So that's what I'm going to be doing with that. I'll be showing everybody how that works. For those who want to learn and how ham radio works, and then also my friends from ham radio will also be watching and going over it and seeing how it works too, because some are doing it, some aren't. There's so many different products now from when I started all this quite a few years ago. The big thing now is digital. The CW and Morse code is no longer needed to get your license, and it's something if you want to learn and practice, it's good. The great thing about it is, again, when we don't have the sunspots, it's in the noise, it can be picked up through the noise. You don't need a lot of power to transfer, but it's old. And again, the military doesn't use it. Most government agencies don't even use it anymore. Everything has gone to the types of digital modes, and that's what we work on. We even do satellite. We have a lot of satellites up, so I can stand here on the ground and use a regular whip antenna and still talk to our satellites. So that's the fun things about ham radio. A lot of people don't realize how much it's changed and what they can do for it. One more thing I got before I go. I bought these. These are special wires. What they are is they're groups of 10, and what it is one set is male to male, one set is female to female, and one set is male to female. So these are great for when you have projects that you're trying to tie stuff together with. You have all what you need, either pin or socket, one way, the other, both, any way you need it, you got it. Again, this was a very inexpensive kit. Looks like I got pieces that fell off, but that's okay, I can fix those. But these are great. They're great to have. And the nice thing about these is they're stuck together in the middle. So you don't have wires, all single wires all over the place. It's a nice, neat wire pack. And then they spread out a little bit here, and they spread out a little bit here. But overall, in here, okay, right through here and right through here, they're tied together, they're stuck together. So those are great things to have. This is all the stuff that we have. This is all the stuff that we're going to be doing. And I hope everybody's going to like what I'm going to be doing. And please watch the channel. We do a lot of neat things. I know some people have asked me already, what are my pictures behind me? Well, I've been doing this stuff for a very, very long time. I have a master's in computer science. I grew up in a family that we did a lot of science things. My father worked for some big companies doing technology that's out now that he was doing back then. So you're talking stuff that's 40 years old that now is going on. But anyways, some of the pictures are the people who I've either met, some of the people I admire. These are people who helped computers and electronics as they are today. I have Linus Tevis, or Linus Torvalds up there. The lady that's in the Admiral uniform, she was a very, very smart lady. Her name was Grace Hopper. She was the first female to run the main computer for the military and program it. She actually programmed the COBOL language. And she is also known for a simple word that everybody knows today. They were having a problem with the computer. Something wasn't calculating right. And she went behind it to look, and she grabbed a pair of tweezers, and she found out there was a fly stuck on the relay. So she turned and took the fly off of it, and she proceeded to put it in her book and sat there and said, "Computer fixed, found bug." So that's where that came from. Okay, the word bug or debugging, that's where it came from her. The gentleman up above her, I like him. He's a very good man. I wish he did more. He was very, very famous. He built a lot of things we use today, but he did not get recognized for a lot of it, and that's Nikola Tesla. He was very smart, very genius. Of course, the man above him, one of my great favorites, Einstein. And I have some other people in there, Aaron During, some of Babbage, some of the other people. I even got good old Franklin, Ben Franklin. Who else do I got there? Linda. I thought I had Linda Lovelace up there. No, maybe not. Anyways, the founders. I got the founders of Alexander Graham Bell is there. Enrico Fermi from Fermilab, which we are about 15 miles from there. I get a chance to go there every so often to see. They have an underground ring like CERN, except for they're just a smaller size than CERN. And I've been there when they've done some tests, and it's been totally, totally unique and a lot of shock and awe. I mean, on what they do and what they come up with. Anyways, hey, thank you for watching. I hope to see everybody again, and I will start my projects again. I was a little bit on hiatus. I got a couple of computers for customers I've been kind of busy with too. So those will be done, and hopefully very, very soon I will have a couple other videos out. So please watch for those videos and hit the like button, and I would appreciate it. I'm trying to do this to help people learn things, understand things. I'm not trying to make it baby style stuff. I'm trying to make it as simple as I can, but at the same time, a lot of these places, they don't explain a lot of different things. They don't show you what they've made changes with. They just said, we did this, we did that. And I like to try to do that, so it gives people more ideas. We do layouts. I'll show how to do layouts. I'll show how to do that. I showed a little bit of soldering. I mean, you know, again, how much can you show people soldering? I mean, it's, you either can do it or you can't do it. And again, majority of people can do it once they know what's going on and have the stuff. So I won't be going over much of that, but I will be going over how to set up equipment, how to put it together, how to make the changes that need to be changed so that it can be expanded and do more. And so anyways, thank you, and have a good time, and see y'all later. Bye.